So for your lab here in the free fall lab, you notice that you went ahead, you got a ball, right? You measured its mass, you got a drop height. That's going to be important. So here, an example, we have 1 meter. And notice we had these various drop times. Now you got 10 drop times. And what we need to do is we need to find g, or an acceleration. Now the problem is, right, we do have a lot of drop times here. And what's going to make this concerning is that you need to go ahead and crank out an equations for 10 of these, take an average, and then figure out a percent error. And this is all going to take some time. But we can do this in several ways, and we can figure out how to go ahead and do this quickly. And it goes back to this. Now, if you remember, right, they actually ask you to use mathematics here. So I'm going to just quickly review this equation, and then after we're going to reformat this equation into something that we can use, so that way we can basically crank out accelerations. So we can crank out accelerations, right? And just plug in times. Now, obviously, this is going to take algebra. So we're going to have to figure out how this equation works, right? Now, first of all, this equation is actually pretty simple, right? And it actually gives you the format of the setup here, right? So y is your distance traveled by the ball. We're going to make it a value y, and later on we'll go ahead and plug in that 1 meter that we have, but we know the distance that this ball traveled is 1 meter for future reference. Okay? And then y0 is the point on its trajectory which can be set to 0. Well, okay, that means we just set it to 0. Yay, that makes it easy. Plus, then we have v naught, your initial velocity. Well, let's think about it. What is our initial velocity? When you had your ball, you were holding it up. And the question is, was it moving? The answer is no. Your initial velocity is 0. And you're going to take that term and multiply by your time, but as you know, anything multiplied by 0 is 0, so this term isn't going to cancel. And this term is not going to be existent, so all you're left with is 1/2 a, which is what we're trying to find, and I'm going to highlight that in red. And then we have t squared, where t squared is obviously your times.
Good, miss. You gave everybody feedback. Good.
Okay. So how do we go ahead and rearrange this? So, well, first of all, we need to acknowledge that this is what we have, right? Y, which is your height, which is 1 meter. And 1/2 of that in your acceleration is your time squared. Now again, right, you go back to your chart and you take this, right? And what you're going to do is you're going to get your things. It's going to be 1/2 a t squared. And you need to figure out what your a is. You know what y is. You know what t squared is. But we don't know what a is. We look at a and we're like, oh, what is this? And again, what I want to do, obviously, is come up with something so I can crank out a's and plug in times, right? So I'm going to be starting from here. Well, this is where it's the part that's going to take some algebra. Well, here's what I can do, right? I know that all these values are multiplied to a. So I need to understand, right? The reciprocal, or the inverse of multiplication is division, right? So it means that we're going to divide by these terms. And I'm going to do it one at a time, just so I can ensure that I have everything here. So y, we're going to start with the 1/2 here. So y, and then we have 1/2 multiplied by a multiplied by t squared, right? We're going to start with the 1/2. So we're going to divide 1/2 on both sides. Obviously, these two will cancel. But what you realize here is like, oh, we're dividing by a fraction. Well, remember, dividing fractions, you do this, right? You have to go ahead and you take this, y over 1, because that works, right? And anything divided by 1 is itself. And then you take the reciprocal of this, right? 2 over 1. And what you're going to realize is, hey, this is going to be 2y over 1. But 2y over 1, right? That's just double my height, right? So 2y. And that's going to be your AT squared. And again, I still want to find A, right? Now, currently this doesn't fulfill my things because I want to go ahead and plug in times. Okay, so I need to go ahead and continue. I know these two are multiplied together, so it's time to divide again. I'm going to divide by t squared again. These two will cancel. And now I have an expression I can actually use where I have A, which is what I'm trying to find. It's going to equal to 2y t squared. And notice this will actually allow me to crank out times, right? I know this y, right? In our example, right, it's 1 meter. And I know my t's, right? I have a whole bunch of them right here. So I know these guys, right? And now I can use this expression to figure out my acceleration. So let's go ahead and let's try it out. Right? I know that my new equation for this guy is A equals to 2y over t squared. Okay, I'm going to plug it in for the first one here. So if A equals to 2y, but y here was 1 meter, divided by t squared, right? T squared I'm going to grab from here. My first one was 0.5. And you square that. Okay? So let's square, well, let's put this all together. We got, let's see, 2 meters, and if I'm correct, right? We got 2 meters divided by 0.5 squared. If I'm correct, that's 0.25 seconds squared. Right? And if I am correct, I believe that's about 8 meters per second squared. And after double checking, right, we can go ahead and we can see so then we have 2 divided by 0.25. Yes, I'm correct. So that's 8 meters per second squared. Okay, and that will result in here. And notice, I know I'm right because this is the unit of acceleration. All right. Hopefully this helps with your lab. If you're smart about this, you can actually even take this to Excel and use this expression to go ahead and you can just plug in your times, crank out accelerations and your percent errors later on. So you can use these skills I taught you and actually get through these pretty fast. And notice now we have this calculation. This is actually going to be really fast too. All right, good luck out there. We'll see you next time. Thank you.